Hi, everyone, and welcome to today's SQL Office Hours session. I'm really excited for today's one because we are going to be designing a database schema. And in order to do that, I will need your help. So this is similar to like I did last year. Some of you, I think, may have joined that. We had a proposed schema, discussed various options, and discussed pros and cons of them. And then we had a vote. And then ultimately, we'll build the schema based on what you decide to do. So it's very important here. Please get involved, get your keyboards ready to put things in the chat and Q&A to discuss the pros and cons of each of the options. So like I say, I'll present them. I'll say, do we want to do it like this or that? We'll have a chat about what the options are, what they mean, and then we'll have a vote. I'll just run a Zoom poll, and whichever gets the most votes will be the option. If by some small chance both choices get the same number of votes, I have got a coin here, so I will flip the coin and we'll make heads the option on the left and tails the option on the right if we ever get stuck in a tie for some reason or other. Don't think that'll happen, but you never know. We'll see. So the schema that we're going to build today is pretty simple, basically straightforward. We're just going to store invoice details. So we've got the invoices header and the invoice item. So, the customer information will go in the header, and information about what each product each person purchased will go in the child table. Basic parent-child relationship. We'll see lots of time. I'm sure many of you have seen many times. So there are a few kind of basic requirements for this that I just want to kind of set out before we get into the details. So first up, when it comes to invoicing, we want to stop people being able to update them. So once we've issued an invoice, you can't change its like who it's for or its monetary values or its total and things like that. That could open up some kind of possibilities of some kind of fraud or dodgy dealing and that kind of thing. So we want to prevent people being able to update an invoice. So it's insert only, basically. Next, we'll want to do some kind of reporting and analysis. And one of the things we'll want to look at and find invoices where the payment and delivery addresses are different. So, I'm paying with my card, which is at my home address or wherever, and I'm getting it shipped somewhere else. So we want to find those situations. And we've also got a requirement to see the total for each invoice. So we've got that master detail relationship, parent-child. We want to know the total amount for each invoice at the parent level. So that's hopefully kind of a bit of an introduction. And I think these are things which we're all familiar with to some degree or another. So the first decision we've got to make is, what are we going to choose as the primary key? Now, we're going to use surrogate keys for this, but there's two kind of broad approaches we could use for deciding how to generate them. One is we are going to have sequence, or they could be identity columns, basically numeric values for these surrogate keys, or we could have GUIDs, like those alphanumeric hex codes, ABC 1, 2, 3, so on and so forth. So the unique identifiers. So what do we think? Anyone want to open us up with any particular pros or cons on either of these options, which you prefer? So I see someone's going for sequence. So I know we're going to have a vote on which particularly you prefer, but I'd like to kind of explain some reasoning why. Why would you use a sequence or identity column over a GUID? What's the pro or con for either of these? So I'll give you a second to kind of think about that. You might be typing away and thinking about your options here, but they say we want to think. So just to recap, we'll have our sequence, could be generated as identity, could be default sequence, doesn't really matter. Point is, it's just a number. Or we've got our GUIDs, which we're storing as a raw. Why not a composite key with sequence and date? Interesting. So what would that be? A sequence of what? So this is our invoices header, right? Why do we need a composite key for that? You can explain further. I'm interested. I'm curious, right? Depends on number of rows. Sequence is easier to manage. GUIDs are more flexible. Okay. Could you expand on more flexible, what you mean by that? Oh, okay. So going back on the composite key, partitioning, what is it? Why does partitioning matter for the primary key choice? GUID is really useful if you have some instance that must exchange data. So this is a good point actually, right? Sequences, you can generate them in your database, but there's very, very likely to be a clash with sequence values in another database. You need to combine the values in one way or another. So that's a good point. So partitioning by date. I mean, our invoices, we can still partition our invoices by date, regardless of what we set the primary key to be, right? It doesn't, those are kind of independent choices, unless you can, I'm not sure how that specific partitioning choice here relates to whether we use a sequence or a GUID, right? Unless you've got some argument to relate it back to those. Partitioning, yeah, okay. I mean, partitioning is must for fiscal years, but again, what's that got to do with primary key values? How does that partitioning in any way influence whether we're going to use a sequence or a GUID? That's specifically focus on that, right? Okay, so sequence indexes would be more efficient, and clustering of data would be better. So, and it's a good point. Potentially, yes. I mean, it depends on how we exactly generate those GUIDs, but the sequences will be roughly sequential, so the values will be more clustered. But is that really a benefit, right? We're looking up by primary key of the invoice. How often do we, search for a range of primary key values? I mean, it may happen, but how often do we do it in practice? Sequences has less size on GUID, maybe a pro or con. It depends. Again, so I don't want any it depends here. Give concrete reasons for or against. These are all it depends, right? Do you need to use the same primary key in multiple tables? Well, we've got the invoices, so the primary key of that will be copied to our invoice items, right? It's the child table. So we will have referential integrity. So whatever the primary key value we set in our invoices table will be copied as the foreign key value to our invoice items table. So we're going to duplicate at least that, right? I just like the simplicity of sequences. Yeah. Sometimes there's something to be said for just saying how we feel about things and what we like, what we prefer there. Any other questions, comments? With sequence, caching is better. Caching what? What specifically? They do give you a rough idea of sequential ordering. Yeah, so it's a very good caveat there with sequences, rough idea, right? Although they're guaranteed to be unique and they generally ascend as long as you've made an ascending sequence, they're not guaranteed to be perfectly in order for a whole stack of reasons. But again, they do tell you roughly which order things were inserted, approximately, right? Sequences can be ordered, and it's true, but that doesn't necessarily guarantee they are inserted in the same order, right? If we've got two transactions, I start first and I generate a sequence number, and then I do a whole bunch of processing, and then you generate this the next sequence number and do less processing, so your transaction finishes and commits before mine for whatever reason. You've committed ahead of me, but so is yours first? Even if we've ordered the sequence, what is the correct order here? You've committed first, but got the sequence after. Got to be very, very careful when it comes to thinking that sequences tell you exactly the order. There's lots of traps like this, which sequences just can't solve, right? Sequences lead to right-handed data. GUID would not, less block contention. So I'm assuming you're talking about the primary key here. So all primary keys are backed by an index. And when we're adding values, because the sequence values are pretty much always growing, not exactly, but pretty much always growing, we're always adding them to the right-hand edge. So we're only having to contend on that, whereas GUIDs can be spread throughout the index. And again, actually, there's reasons why either or both of those might be preferable. Yeah. Also in rack, each instance has its own sequence cache, which can affect ordering. Very, very good point. So with rack, we can have multiple instances running at the same time. So let's say we've got 4 machines, servers running the database. Each has its own set of numbers that it's assigned. So the first one will get like 1 to 20, the next will get 21 to 40, so on and so forth. So, they might be ordered within the instance, but they're not necessarily ordered across the database, right? Integer data type is more efficient than raw. Primary key has to be unique, but it doesn't have to be meaningful. Oh, very good question and point, right? So these are surrogate keys, right? In kind of relational theory or database design, these surrogate keys should be completely meaningless. In theory, it shouldn't actually matter whether we use a sequence or a GUID, because no end users should ever see this. I know that the way we build systems, that isn't always true, but yeah, it's a good point. And might influence our decision. If the invoice will ultimately go to a customer, it would be simpler for a customer to quote a sequence over the phone rather than a raw GUID. Absolutely, very good point. Reading back a 32 character thing is not the most fun. Whereas even in really busy systems, you probably end up with maybe a billion invoices. It's still just a 9-digit number. Okay, so I think we've covered had a lot of discussion. I think at this point we need to actually have a vote on it, right? So I'm going to open the voting up, and hopefully you can see the poll now. So place your votes, put them in. I'll give it a minute or two to go away. I can see lots of you voting. Thank you. Let me just check and see if there's any other things come in while you make your decision. I'm gonna have to remember, what I've chosen here as well. Good point on right. I think I got everyone's comments here. If I didn't, or there's something else you want to make, just say. So I'll give you another second or two to give your. I see not everyone's quite voted yet, so come on, don't sit on the fence. Make a choice. We're not gonna judge you. We don't know who's made which choice here, really. So I'll let it run for another few seconds. All right, then. And we go from 5, 4, 3, 2, 1. All right, time's up, and I will end the poll and share the results. And 82% of you have gone for the sequence. So very, very solid winner there with the sequence. All right, well, so I've written that down. If someone else could make a note of this, just in case I lose my train of thought or the plot of where I'm going. So first decision made, sequence. Next thing we need to think about is we want to prevent updates. As I said, once you've issued an invoice, you shouldn't be able to change it. We want to stop potential instances of dodgy dealing where people issue an invoice and then change the values later and things like that to kind of do some kind of financial fraud or limit the chances for it. So how are we going to stop customers or end users of the system editing invoices and make sure it happens? So there's two basic choices I've come up with here. One is we can use a blockchain table. The other is we can use a trigger. So for those of you who are not familiar, blockchain tables is something we introduced in 21C. We've backported it to 19C since. It's got this syntax, create blockchain table, and it is essentially an insert-only table. Once you've inserted data, you cannot update it. Like, the database will prevent you. You can't update it. You can delete, although there's some limitations on that we'll discuss later. So it is insert only. And there's we'll talk about more of the details of these a bit later, but the key point here is once a row goes in, you can never issue an update against it. The alternative, the kind of old school way or classic way to do it, we could create a trigger. And it's just a before update trigger. As soon as that fires, it just raises an error, right? Instantly. So basically, no one can ever issue an update as long as that trigger is active, of course. So those are kind of the two options I'm proposing here, blockchain tables or triggers. What do you think? Which would you go for? What are the pros and cons for each one of them? See, someone's come up with a third option. It's always good to see a third option. I like to keep these for two, just to keep things easier and manageable, make sure we have a clear winner. But someone's saying in a third method, SQL Firewall and release 23 and 23C. Yeah, I hadn't thought about that. That's a good, interesting idea. Maybe we could discuss that as an option in a future session we do here. Which one is faster or less troublesome in maintenance? I don't know. You tell me. Which one is faster and less troublesome in maintenance? Blockchain tables or triggers? I guess it depends on what you mean by troublesome or faster. This is a good point, though. Which is going to make your life easier? I've got to vote for someone saying blockchain is more explicit, but need more knowledge. So when you say need more knowledge, do you mean you need to understand the feature better, or developers using the product, developing against your application, need to understand it better? Got some votes. Maybe just an immutable table without the full infrastructure of blockchain tables. We'll come back to immutable tables a bit later. There's another good point. It's quite often a third option available here. Okay, so I've seen someone else coming out with another option, read-only database. I'm not sure if it's a read-only database. How do we insert the data? Okay, we still got to insert the invoices in the first place, right? Remove grants for app role. Yeah, that's another option. Is we don't do either of these, and the application user only has inserts and maybe delete privileges on the invoices table. It's a good limitation, but again, it's one of those useful but not necessarily sufficient. How do we ensure backend jobs don't come in and break things? Restriction on VPD level. That's yeah, we could use virtual private database to have policies to prevent updates. You're coming up with good options here. I hadn't thought of several of these. A read-only partition. Okay, yeah, I mean that helps a bit. We can insert but we'd still be able to update for a brief period. I'm assuming we've got daily or monthly or whatever partitions. At the end of each month, we make the previous one read-only. That'll stop people updating past invoices, but it doesn't stop like the immediate effect, right? I've issued an invoice and it's like, oops, I've made a mistake, or oops, I want to fiddle the numbers, editing it straight away, right? But yeah, something to consider. Will you ever need to do some maintenance on it? An admin or change due to release logic? What kind of maintenance do you mean, right? It's a good question, though. Trigger anything with a blockchain in the title gives me the heebie-jeebies. Yeah, I mean, there is a lot of hype and discussion around blockchain. This is not blockchain as you might have heard in terms of cryptocurrency, but it's a specific implementation in the database. But yeah, it's a good point. To people like blockchain, is it useful? That kind of thing. I understand triggers, but they can be bypassed or invalidated. So an inbuilt blockchain feature may be preferred. Very, very good point. I think most of us at least understand conceptually what triggers are. And so other developers and DBAs will be familiar with them. But as you say, they can be very easily bypassed by disabling them. And some cases you might actually need to as part of like a background. Someone was talking about doing some maintenance, right? So it doesn't guarantee that no one's ever changed the data, right? If we use a trigger. If so, blockchain would be harder to deal with, I think. I mean, I'm not sure. I mean, there are some limitations and some things to be aware of with blockchain, but I don't think they're particularly onerous or overhead. Very good question. Can new columns be added on blockchain tables? So when this feature was added in 21, you could not add a column to the table. Okay, very serious restriction there. That restriction is lifted in 23C. Okay, you need to create a new version of the type, but from 23C, if you've got blockchain table, you can add columns to it. So very important point. That's probably one of the restrictions which most people will be like, I can't create a table and not be able to add columns to it. That sounds not great, right? So the answer is you can from 23C on that. Are there any instances where the trigger may not fire? Well, ignoring ones that you've coded yourself, it's if somebody's disabled the trigger manually for whatever reason. There might be, I'm not sure of any others why the database might not fire the trigger. But the point is, you can just connect and do an alter trigger disable, right? And how can we stop that? Or how can we, be sure that hasn't happened? Triggers allow more control, allow partial updates like comments. Yeah, we might need to update some of the invoice, right? Like the payment date, maybe. Okay. All right. And we've had a lot of discussion, a lot of good things here. So I think at this point it's time to go into the poll. Brought that up. That should be able to see it. Please put your votes in. Oh, this one's quite close so far. So very, very close. In fact, come on, votes come in. Put your votes in. What do you think this is? I don't know which way this one's going to go. We are pretty close to 50-50 here. Go on. I see not everyone's voted yet. So put your votes in. Let me just kind of check see what things have been put in there. I'm just going to run back through the comments. So okay, I think I've addressed everything. Someone's saying read-only table space again. Something to think about there. This is. Am I going to have to waste my gaming cycles on my GPU for blockchain? No, right? So blockchain in Oracle database has nothing to do with GPUs and Bitcoin mining or anything like that. Really, the actual principle is very simple. We create a hash we have an initial row, kind of like a dummy initial row you don't insert, and we hash that. And then for each row you insert, we create a hash of the values for the row alongside and include the hash for the previous row in it. So basically you end up with this chain of hashes. That's where the chain concept comes from. So we have to store that hash in the table. Nothing to do with GPUs in database terms, right? Are there any other disadvantages of blockchain table? Like, can they be partitioned? As far as I know, they can be partitioned. There might be, they say there were some restrictions in 21 around adding columns. There probably are a few other restrictions, which I forget off the top of my head. But yeah, you can partition and most database features will work with them. Okay. All right. So I think not quite everyone's voted, but I think we've covered most of the things. And like I say, this one was quite close. I wasn't sure which this way was going to go, but if we end the poll and reveal the results, blockchain tables take it. Okay, so I'll write that down. Blockchain tables just right. That was like 53% to 47%. Interesting. Nice to see you're all trying these new things out and giving them a go. All right, so let's stop sharing, put that back. All right, so let's move on to the next choice. Now, this is probably an interesting one. What units are we going to store the monetary values in? So there's two basic approaches. We can store in major and minor, so pounds and pence, euros and cents, dollars and cents, that kind of thing. Or we can store it all in the minor unit, store it in pennies or cents or whatever you consider. So if I'm storing it as pounds and pence, I'm saying it's a number with two decimal places, and those two decimal places are the pennies or the cents or whatever it is. Or we can store it all just in pennies or whatever the minor unit is for your currency. Right. Questions, comments on this? What do we think? Votes one way or the other? This one's a bit more of a philosophical one, I think, right? I'm not sure that there is definitely a difference. You need to know which you are storing your values in. Are we storing pounds and pence or just pence? Question, what about exchange rate? Very, very good question. Something we need to think about when storing monetary values, but I'm not sure it directly affects our choice here. Can you have sub-minor units? So if we've got, before the UK went to decimal currency, there was all sorts of things. There was pounds, shillings, pence, farthings, and all sorts of fractional currencies. I don't know that there are currencies nowadays that allow it. Historically, there was. I don't know that currently there are. I don't know, right? I'm not a currency expert. Maybe there is still. Integer max value. So an integer is just a number, right, in the database. So it's the same 38 digits of precision. So if you've got buying something with more than 38 digits in it, I mean, even with those currencies with hyperinflation with whatever millions to the dollar, so I don't think you need to worry about it. Basically, it's not like a PLS integer in PL SQL, which does have, what is it, 2 million limit or something like that. That's 1 for you, 19 for me. Yes. Yeah, 1 for you. Minor only probably requires conversion before storage and on retrieval for human consumption. So major minor probably simpler to use. Yeah. That's a good point, right? If we store just in pence or just in cents or whatever the minor unit is, we are almost certainly going to have to convert it into pounds and pence or dollars and cents or euros and cents whenever a person views this, right? So however we store it, if we store in pennies, we'll almost certainly have to do some display conversion. I suppose you can have something that you're buying in 1 million units at well, $1.2222225, multiple like fractional digits of precision of even the minor unit, fractional pence. That's a good point, right? Let's assume we've got a business that doesn't do that. We ignore fractional pence and cents, at least for customer facing things. But there are, petrol, gasoline, most places, actually, it's the pence per litre or gallon, and it's something 0.9 of a penny, right? Or 0.9 of a cent. So some things could have fractional. I mean, I've assumed it's just, we might need more decimal digits of precision, right? Someone saying taxman, yeah, good point there. Maybe star 4 instead of star 2, right? So we can have more precision for the minor unit. Good point. Yeah, you need to think about these fractional. Do we allow fractional precision? If so, how much precision do we want? This is for the minor unit, right? Yeah, no, if you must support currency exchanges, again, yeah, exchange rates, we might want a bit more extra precision for the converted value that we store. Number so that fraction precision capture is better. I mean, I've just done number 2, star 2 and integers just to help make things clearer. Maybe we might not use these exact data types, but the point is are the decimals fractions of the major unit, the pound or the dollar, or are they the fractions of the minor unit? Major or minor, less error sensitive. Hey, can you explain that? Why do we restrict to decimals? Because most currencies, the minor unit is 100 to the whatever the major unit. There's 100 pennies in a pound, 100 cents in a euro, and 100 cents in a dollar. That's true for most currencies. Not all of them, but most of them, right? I've worked on systems that have something like this, right? That's why it's number 2 decimals. We might do in real world have more decimals, but again, I just want to make things hopefully a bit clearer in this thing here. Okay. Are we talking about invoice total or rows value? Either. Any monetary values we are storing anywhere in the database. There'll be prices on products and stuff like that as well. And probably order items will have a unit price on them and so on. But we're only focusing on invoices to keep things simple for today, but any monetary values we store anywhere in our database, because we want to use the same system, right? You don't want to have major and minor in some and minor in the other. That's a recipe for disaster. Okay, in some SAP chart exchange data format, currencies have 3 digits after the decimal point. Interesting point, yeah. 8 digits after the decimal symbol on our shop here on unit prices. Enforced by law is the exhibit of 2 decimal places on total values. Interesting. That's an interesting thing I know. Should we be concerned when it's used in PL/SQL? So we're not going to forget PLS integer. Ignore PLS integer. That's nothing to do with this discussion, right? It's just, are we storing major and minor? So we've had some discussion at this point. I think let's get the poll open, because I think we need to move on and get through these things. So what are you going to vote for? Oh, votes storming in. Good. Come on then. Let me just check. What if you need more than 2 decimals? Yeah, I mean, like I say, we might store with more than 2 decimals. You might want to have fractions of a penny as well. I've just used major and minor. I've just done 2 decimals to make it clear that the major unit, after the decimal is the minor unit, right? Whereas if it's minor only after the decimal it's the minor unit before the decimal, right? Okay. Any other things coming in? Any other votes? Not quite everyone's voted yet. Let me just Major and minor, less error sensitive. Don't need to worry about PL percentages, more than 2 decimals. I think might have missed some. Hopefully I've addressed everyone's comments there, and I think the voting is pretty much stopped. Most of you voted, and there's a very, very clear winner this time. Let's just end it and share the results. 81% of you, major and minor, right? So let me just make a note of that. Major and minor. So we're going to go major and minor. Okay. So the point here is that anything after the decimal is the minor units. Anything to the left of it is the major units. So pounds, dollars, euros. Anything to the right is pennies, cents, whatever the smaller unit is called there. Alrighty then, let's move on to the next choice. We've got 2 more choices left, and then we will be done. Then we'll start building this. All right, so next, we've talked about calculating this total paid. Do we actually want to store it on the invoice header? So we've got the invoice items. So for each invoice, there's potentially multiple products they've stored. For each of those, we're going to store, for this product, they paid this amount, or unit price for that item that they purchased. Right? We're going to store it at the item level. Do we then also sum those values up and store them at the header level as well? So on the invoice header, do we pre-calculate and store what the total is and explicitly record it in the database? Or do every time we need to know the total paid for an invoice, do we run the query, do the group by invoice ID and sum up the values within the invoice items? So just kind of recap. With storing, we've got our invoice item header, parent row. Do we sum up as part of inserting the invoice? Do we sum those values up and store them explicitly on the invoice header? So we've got a column for it. Or do every time we need to know this value, we calculate it? We run the query to do the group by and sum things up. What do we think? Choices, arguments for and against. Calculate impact performance. Impact it how? Go on, how does it impact? And how does not calculating it, how does storing it not impact performance? Absolutely stored. And in blockchain table, I guess, I think taxes and electronic invoices, the less you calculate, the less trouble you get from the accounting department. So, yeah, it's a good point. Once it's stored, then you're not recalculating it, and it's an absolute value. Disks are cheaper than CPU. Well, there's, it's, I guess there's a point. Don't store, calculate, or create a view that includes the total. Store because using blockchain. Do you need running totals as you add items? So that's a good question. Do we need running totals? Because a lot of businesses will just issue, once you've finished or part of placing the order, they'll issue the invoice, right? Other types of businesses, you might build up the invoice as you go along, and you may not actually, the invoice may not be complete. And it might take several minutes, hours, maybe even days potentially, and things could get added to it after the fact. I'm not sure businesses run over that long at the time, but it's a good point. Do we need to go through a multiple transaction process, right? We have separate transactions adding those invoice items, and do we then actually need to calculate the running total as part of that? It's a good question, right? It's undefined at the moment. Store because using blockchain. Chances are you want to aggregate totals further, daily, weekly, so more efficient to avoid summing item rows each time. So you mean store on the header because you probably want to run multiple levels of aggregation. Is that what you're saying there? Yes. Okay, cool. If an update of the invoice items is blocked, then I would also store it in the invoices. But if updates of the items is still possible, differences can occur on programming mistakes. Yes, okay, good point. So remember, we have gone with blockchain tables already. So we've already locked that decision in. So we are on blockchain tables. That influences you think. Sorry, sneaking the slides. How can we store as header if the table is unupdatable? Well, it would just be part of the insert. You'll have an API, and as long as you calculate it in the transaction, you can pre-calculate all the values, calculate the total, store the header, and then store the items. I'll show you, right? I've got an example in the demo. Whichever way we choose, I've got an example. Might give some performance benefit if it was pre-calculated and stored. But if an invoice update is blocked, how you set it in the invoice, they say as long as it's all in the same transaction, which we can do, we'll assume it's all in the same transaction. I've built an API. We'll just insert all the items. We can calculate all of those, do a pre-calculation of the total there, insert the header, then insert the items. If there is a possibility to accept an amount which does not sum up to the correct total, bank transfer is out of control, they may pay the wrong amount, then yes, store total too. That's an interesting point, right? Invoices, we think it's always just the sum of the total, but we need to handle error conditions, right? What if something weird happens? What if we've got discounts or buy one, get one free? How are they stored and calculated? If the invoices are not updatable, then you cannot build it in several transactions. Exactly. If it's not updatable, we can't build it in several transactions. By storing, you risk the possibility of data anomaly. Yes. The amount is not the same as the calculation of the items, right? What if we make a programming error? And in our API, are the items being added in different transactions? Contention on the total. So in this case, we'll keep things simple. One transaction will insert all the data, the header and the detail rows. So it's all going to happen at exactly the same time. So we don't need to worry about cross-transaction consistency and concurrency. We'll keep it simple, right? Any other questions, comments on that? I think we've got quite a few come in, so we need to move on or we're going to run out of time horribly. So I'll start the poll. So hopefully the poll you can see there. Make your choices, vote, and I'll just double check and see if I think I got everyone's comments, but I would store it in dice. Yes, yeah. Right, that's live. Send the invoice, right? Okay. I think I got pretty much everything. Most people's votes are in. A few people still not voted yet. Last few seconds to get your vote in. It's analytic functions would help. Well, it could do. I mean, they might for running totals certainly. Analytic functions would help definitely. So it's fairly close this one. So I think we need to move on. So I'll end it. Most people have voted at this point. Share the results. 53% of you went with store on the header. So storing is the winner. So we'll click that. That's the storing. So that's what we're going to go with. So 53%, 47%. That's fairly close. I wasn't sure which way that one was going to go, right? That was closer than I expected. I'm not sure what I expected, to be honest, with that one. All right, then. Final decision we're going to make. We was robbed. Okay. Final decision. In addresses. Okay. So obviously they've got invoices. There's going to be address details. At least two addresses, the payment address and the delivery address. There might be more as well, potentially. So are we going to store those inline in the invoice header, or are we going to have a separate address table or addresses table and foreign keys back to it? So I've kept, there's multiple parts to an address, obviously, but I've kept it kind of simple here to just hopefully make the point. So you could have in the invoices header, we would have columns to represent the address for the delivery, columns for the payment. There might even be a separate customer address or legal entity address for the customer, which is different to both of these in some cases. Or do we have a completely separate table to store the address details and then just have foreign keys to it? I need to watch my cursor. It keeps flicking through things. So questions, comments, what do we think on this? So separate table to keep it normalized, right? So very good point. An address could be used multiple times. Certainly most businesses hope they have at least some recurring customers, repeat purchases. If we store it in the invoice every time, we are duplicating that information potentially lots and lots of times, because we've got lots of repeat business from customers. Probably I would have a separate entity shipment. Okay, that's a good point, actually. We haven't talked about shipments. At least thinking back, I did work on an invoicing system years and years ago. I'm pretty sure we actually stored the delivery address on the invoice and on the invoice and then on the delivery shipments table as well. But yeah, it's a good point. We might need to do that. Separate table, easy if other address gets added. Okay, so we've got to have new addresses. Separate table provides more flexibility. It allows for customer address changes, so outstanding invoices can be forwarded. All right. We don't want to allow people to update the addresses on an invoice, right? We said we can't update invoices because that also, again, could be a potential, dodgy / fraudulent attack thing. You issue the invoice, ship it to somewhere, and then sneakily later on update it to ship to somewhere completely different. We don't want to allow people to do that, right? Because that doesn't sound like a good thing, right? If customers need a new address, we cancel the invoice. We issue a credit note and create a new invoice. We don't update the addresses, right? IDs are good when the street name changes from some newly disgraced person to someone else. Disgraced person, interesting. I'm not sure. Not quite sure what you're getting at there. Oh, feigning ignorance, right? So we've got separate table, in fact, consistency updating. So you're saying we can update the separate table, but not the original, right? Addresses should be put in normalized address dictionary. Separate tables is better for reusability. When stored inline, I would prefer storage as an object type instance, but normally I would store it in a separate table. And that's a good thing, actually. I haven't split out how we're storing the address details, and keep that in mind because we'll sort of talk about that in a bit. Separate table. Amazon lets you change the delivery address before the item is shipped. Oh, interesting. Okay. I mean, yeah, it depends on the business, right? And where you're going. Certain types of businesses will not let you. Certainly, it was a business to business thing, not a consumer retail environment I was working in where, potentially we didn't want to allow things like that. But again, depends on the business requirement. You need to think about these things. Since this is a referential database and not NoSQL, referential is always going to be the right answer. Okay. Separate, I may want to protect payment location and delivery locations because of privacy concerns. So that's a good point, actually. Something we haven't talked about. Whoever can view invoices, we don't necessarily want people in finance who are processing invoices or the payments processing team or whatever, or customer support to necessarily be able to view the addresses, right? Or certainly not the full address anyway, because there might be, say, privacy concerns, GDPR. You don't want people to necessarily see that kind of information. All right. All right, I'm gonna start the voting on this because we do need to move on. And so let me just open this up. What is going on here? Why is it doing that? Why launch? Why is it not letting me do this? It's not letting me start the thing. Oh, I need to stop sharing. That's fine. Launch. There we go. All right. So addresses. Are we having inline columns or a separate table? Which are we going to go for? Whoa, very clear winner this time, right? Very clear winner, at least so far. The votes are pouring in. I think you might be able to guess from the comments we've said who's the clear winner. But if you want to stand a chance of influencing things, vote. Still a few people not voted yet. I think most of you have voted at this point. Okay, I'll leave it open for a few more seconds and then share the results and we'll build the actual schema. Okay, so yeah, the results aren't going to change now, so I'm just going to end it and we can see a very, very clear winner, separate table. So we're going to have a separate table for invoices. 92% of you went for that. Very, very clear winner there. Alrighty then, let me stop sharing that and let us actually build the schema. Yay! So I've written things down. Let's jump into the demo and see how this actually works. So let me just check I'm connected. There we go. Good. Something a bit dodgy there. All right. So first up, we were going to have separate tables and we were going to have sequences. So let me just remove that. So we're going to create our addresses table. Someone's talking about object types. I'm storing it just as JSON for now to keep things easy. Maybe next year we'll have a discussion about storing addresses because that's a massive topic. But for now, I'm just going to say it's an address and it's just one thing, and we're going to stick it in a JSON because there's too much to talk about for addresses otherwise. And we want the addresses to be unique, right? We don't want to have duplicate addresses in this JSON value. So I'm going to have a unique index on it. So there's our table. We said we were going to go for blockchain tables, right? So let's do the generate identity sequence. We didn't want to store them in line. We didn't do that. We were going to store the total, and we were storing with major units, so not 10-2. If I make a mistake on any of this, do let me know. For the blockchain table, we also have these things we need to add at the end. I'll talk about those a bit more detail in a minute. So we've got our sequence, we've got our addresses table, we've got our total, and we've got our blockchain, right? That's right. Yep. Correct me if I'm like making a mistake here. So let's create the invoices table. We don't need the trigger. We can ignore that. Again, with the invoice items, we got blockchain, foreign key back. As I said, we've got the unit price on the thing. We've got the major unit, and we need our blockchain commands there. We've got that. Don't need the trigger. I can delete that. I've got my package. This is just to insert some invoices so we can stick some data in. So we accept an array of the items that they purchase. So the address table true. So I'm going to use conditional compilation to actually manage this. Those of you who are not familiar, we end up with these $$ things. If this condition is true, then this code gets compiled, this function, add address, we need it. We're going to insert addresses and trap the exception if we've got an existing address. So if I set that to false, this would not be compiled in the package. Again, this is a big topic, conversation for another day, but just for, I've done something wrong there. What's broken? Not enough values. Oh, I think I know what I've done there. Sorry, I missed something because I needed to do store total, invoice total. Dang it. Does this? I think this hasn't worked. Store total true. What have I done wrong? This is where I go. So notice we're going to build up our total before we insert. Let's just remove some of this additional compilation because there we go. Oh, I still got it wrong. What have I done? What have I done? Let's just bring up the package. So I'm running on my always free 23C free database, and let me just compile that. Not enough values there. Yeah, what's going on there? Oh, it's doing the conditional. It's not picked up the change there. Why has it not done that? There we go. Not enough. That's. Oh, did I not? I didn't set that. That's probably why. There we go. Oh, it's because I forgot to actually execute this. You know, excitement of building our demo, right? Okay. Anyway, if you notice then, if I actually refresh that and pull it up again, you'll notice, you should notice, I actually will add $ compilation. Anyway, let's move on. We've got to move on. So we were storing in major units, so that's true. And we're going to store the major units. So we're not going to multiply the values up. This will store in pounds and pence. And I'm just going to insert some different invoices, 3 invoices, one with payment address, delivery address, one with the same delivery address. So we got some invoices in. We had a separate addresses table. So we've got our things here. So at this point, we can see our table and we can see our address information. Okay, so far, you know, we've had to have an extra join to bring in the addresses, but yeah, not too much to kind of say there. So let's look at these addresses. One of the things we said we wanted to find is invoices where the payment and delivery address were different. We want to do some reporting or whatever. So because we used our foreign keys, we can just compare the IDs are different. Nice and easy, right? Pretty straightforward. If we'd gone with the other approach, we could have done it as JSON, not JSON equal, but it's a bit more complicated, right? Particularly if we actually had separate lines for each address and there'd been multiple things that we needed to compare here. Could get a little bit fiddly. So actually this comparison is quite easy. If we want to look at an address that's been used many times, so notice we've got 2 columns in the table here. To find out if it's actually how many times it's been used and how many different invoices, I actually want to turn those into rows. So rather than a payment and address column, I want a payment column, address column, and a delivery address column. So I'm going to unpivot that. And then this query will find that. Actually, I need to pull this back in so we can find out what those addresses actually are. So that does the job. And again, the difference between inline and separate table here isn't actually that big. I just needed to actually join to pull that information in. Although the unpivot is potentially quite a lot easier than to lots of separate inline columns, which we might have had. Now, here's where things might get interesting, right? We made the invoice and the invoice items table blockchain tables, but we didn't do that on the addresses. Oopsie. So we can update. Updating an address is now very, very high impact, right? So notice I've got these to a new address. Let's just roll that back so you can see they were same address. So this is the big argument I've seen a lot of people use, and why people, systems I've worked on, have stored invoice addresses inline on the physical table, because it becomes very easy for people to not realize they're supposed to not update addresses, and then do some minor changes which have massive ripple effects across your whole database. I'm not saying now, generally from a normalization point, that is actually a good idea. But from like a compliance and regulation, auditors hate this stuff. If there was an invoice to one address and suddenly the address changes, and they absolutely hate this stuff. Now, again, we could have made the addresses table blockchain too, something maybe to think about and overlook, but maybe we don't want to, because we might want to update it for other things as well. Someone's saying "told you," right? Someone foresaw this problem, right? And they say systems I've worked on have absolutely required addresses to be stored inline to prevent this problem happening, because again, addresses are messy, right? Ensuring that two things are actually different addresses or the same is really fiddly. Again, maybe we'll do that next time. We'll do a vote to discuss how to store addresses, but it's a massive. Usually, this normalization effect is really, really good. But from a compliance and regulation standpoint, yeah, auditors get antsy about this stuff. All right, let's move on. So preventing updates, we made these blockchain tables. So we got the operation not allowed. But we've also can't delete. Well, we can't delete yet. I said there was some other things. So we've got these extra clauses: no drop till 0 days idle. When you are testing, make sure you set this to 0, because you can set it to higher values. You can set it to a week, a month, year, like a year or something. That means you cannot drop the table for a whole year after you create it or after you insert data into it. Set this to 0 for testing. And in production, think about what you actually want the value to be in. We can also disable delete, for a certain number of days after you've added a row before you can remove it. We talked about adding and removing columns. We have to set it to version 2 so we can add or remove columns. So we've got blockchain tables. Someone else mentioned immutable tables. They're like blockchain tables. They're insert only, but they're a bit more lightweight. And we got our standard regular heap table with our trigger to prevent updates on there. We go to, I think you can't update that. All right, so let's just insert some data in them and save that. We've got 1,000 in each one. Now, the first thing to notice is, how do we know this blockchain stuff? There's a whole stack of these hidden columns here. If we look, there's this hash, right? This is the blockchain, essentially, these hash values. As you can see, they are quite big, right? They require a lot of storage information, and there is a lot of extra metadata about the rows we've inserted. Immutable tables have the same hidden columns, but they don't store the hash, which can be quite a big space saving. We just compare the size of these. So these are example tables. The heap table, 64K, the immutable table, double the size, and the blockchain table, double again. Okay, so there is a lot of storage overhead for blockchain tables. If you want that kind of real cryptographic security, to be able to nuts and braces say to your auditors, this has never changed, you need this. But in most cases, that's a lot of overhead, right? Do we really need that overhead? Now, as I said, the great thing about, in all these instances, we can't update the rows. Blockchain tables doesn't allow it. With our heap table, with our trigger tells us we can't do it. But there might be some columns we want to change, right? We might want to set an invoice to paid. You might issue it and it is paid at a later date. Blockchain tables, can't update it. Invoice is currently, we can't update it. But as someone said, we can actually selectively say when this trigger will fire based on the column. So it only fires if we try and change these columns. So now we can set the payment date. We can update the row, but we still can't update the customer and other information, which is disallowed. But with our blockchain table, you can never update anything. There is no way to selectively say some columns are updatable and others. As you say, we're talking about removing rows. Blockchain table, we can't yet. Immutable tables, we can't yet. The heat table, we can. If we want to say that a row has to have existed for at least a year or something, we'd have to code a trigger for that as well. So at this point is like triggers allow us some flexibility. Why don't we allow it? Well, let's say we can say there's currently no invoices for customer ID 0. Someone could disable the trigger, right? We can update it and then we enable it and everything's for customer 0, right? This is probably one of the big downsides of triggers is it is very easy to bypass them. Now, this is probably good enough for kind of casual attacks. If someone in sales and marketing or whatever is trying to update invoices to kind of fudge their figures, a trigger is probably good enough. But a sophisticated attack, someone who's got support from DBAs or software development, they could absolutely come in and disable the triggers. Again, this will depend on your requirements and how strictly audited you are. Some of them might say this is the fact you can disable these triggers is not good enough. We need to be sure you cannot edit it. You could turn on auditing. Yeah, I mean, turning on auditing will trap the fact that this has changed, but it doesn't stop it happening, right? And, this comes down to how strict do you need to be? Yes, you can find that it happened and catch the people who did it potentially, but sometimes it's better to just stop things in the first place, right? So halfway house, or something you could try. Immutable tables has the restrictions of blockchain, but less overhead. We don't have that storage hash overhead. So we can store the stuff which cannot change in the header table. And then we can have separate tables for the updatable stuff and just a regular heap table. And actually, there's arguments why you might want to do this anyway. Like say, if for payments, there might actually be multiple payments against an invoice. You think expensive things like cars, holidays, building work, you might make multiple payments. Having a single payment date column may not make sense. Might better have a separate table with payments made and their totals. So actually there's arguments why you might need to split these updatable values out into separate tables anyway. But with using an immutable table, if you just want it to be insert only and don't need that full kind of cryptographic security. So we can update payment date, but we can't update the fixed information. All right. GUIDs versus sequences. Okay, so keep it simple. I'm just going to have one column each one, a GUID and a sequence, and we'll just look at some kind of performance stuff. So I'll start that running. So 3 times I'm going to insert 50,000 rows into each table. I'll just do it in a loop to kind of get some performance metrics. This will run for a few seconds. There we go, and it's done. And you can see broadly speaking, they're actually fairly similar, right? We're talking this is microseconds here per execution. We inserted 50,000 rows in just a second and a half. They actually come out fairly similar performance here. I haven't done any, there might be some performance tweaking and tuning we can do here. But broadly speaking, they actually perform similar when it comes to inserting, at least in this example. Obviously, if you really, really care about performance, test and run in your own database and check and validate things yourself. The big difference, however, comes in the size of them, the space consumption, right? The sequence, the total space used by the sequences is whatever that is, 588 bytes versus whatever 2.4 million bytes for the GUID. So the sequences here are 4 times smaller, right? They use considerably less space. And you might go, well, and we can see in terms of allocated space, we've allocated nearly double the space for the GUIDs. You might go, disk is cheap, it's not that big a deal. Remember, these are our primary keys. they're almost certainly going to appear in a lot of child tables as foreign keys. So we're duplicating this value. That could add up to a substantial difference in actual how much space you're consuming, and it has an impact on how effective queries are, use of the buffer cache and memory and things like that. In order to get to a number that's about the same size as a GUID in terms of bytes, that's however 30 digits, 999 octillion. All right. Even if you're Amazon or some other major mega retailer, you're probably not going to issue that many invoices, right? Not anytime soon, anyway, right? So, as we saw, when it came to inserts, they performed similarly, but sequences are just substantially smaller. And as other people said, there's kind of usability benefits for them as well, because they're just smaller, right? So if we look at what these numbers are, someone repeating something like that versus something like that, it's just easier to kind of manage and so on. Currencies. All right. So we went major and minor, so we can see that now already. So this is already looking a bit more like what we end consumers want to see: pounds and pence, dollars and cents. But we don't necessarily know that. We don't know what they're stored are. We're just kind of trusting that that's what it is, right? We need to be sure of it. So I'd recommend creating a currencies table, which says how many minor units or how many minor units decimal values there are in the major units. Because, as I said, most of the major currencies, there's 100 minor units in the major, but some Japanese yen and Icelandic krona have no minor unit, and there's actually quite a few. Mostly the Middle East and North African dinar, Tunisian dinar, Kuwaiti dinar, Bahrainian dinar actually have 1,000 whatevers they are in the dinar, right? Three decimal places for their minor unit. So, people are talking about should it be a number 2 or a number 4 or 6 or something. Yeah, you need to think about that. But whichever you're going to do, it's probably worth creating a standardized function to display the price. And there's a little function here, and I actually do the conversion here. So I've got the units. What did I say? We were in. I'm going to have to remember which way around this is. No, that's not. Have I done something? I missed a step, haven't I? I've not inserted the data. That's what I've gone wrong. Let's insert those. And there we go. So our minor units. So this would just convert. This is saying how many units, how many decimals are we expecting in pennies and things like that, and doing conversion. Don't necessarily have to do this, but I'd strongly recommend making a standardized function to do it, to help you kind of manage this. Make sure you do the rounding consistently and things like that as well. Another thing you can do, 23C, we've got annotations. We can say store in minor unit or store in major unit, whatever you want to do. Well, annotating this column to say what it is. So documenting it at the column level so people know how they're supposed to use it. So this is something we've added in 23C. This is column comments on steroids, much better column comments, annotations. Document this information and make sure people know how it actually works. All right. Invoice totals. So we stored the invoice total and we had the customer total there. So let's just put that. And as some people said, if we wanted to calculate it, we'd have to do a join like this and group by and so on. So let's run that. And it's like, oh, hang on. Uh-oh, those values are different, right? Flip backwards and forwards, 33 versus 168. What's going on here? I'll whiz past it super quick. But I actually had a bug in my code, right? This invoice total should be invoice total plus, right? I made a mistake. And this is perhaps one of the reasons why you don't store, right? Logical errors can get stuck in, probably not as obvious as this, but maybe rounding errors and things like that might creep in. Or of course, maybe you need it because you need to manage rounding in a specific way. Logical errors can creep in, and particularly if we've got a blockchain table that you cannot then update. We've got a whole stack of invoices which we'll just have to cancel and reissue because the total doesn't match what the actual total is at all because we made a coding error. So this is the risk you take with storing duplicated information. So what would I do? Well, there's another way out of it. Let's create a materialized view, and then create materialized view to pre-compute that information. So now if we run this query, this is stored the result of this query. And we actually, when we run this, it's the correct total. But if we just look at the plan quickly, it is, you can see material map view rewrite access. It's getting the information out of the materialized view. Okay. So rather than storing explicitly as a column on the header, I say maybe of the specific rounding logic or something you need. So the actual sum of the totals doesn't necessarily exactly match the sum when you account for rounding. You might need to do this, but in general, I would create materialized view so you pre-calculate and store that result, so you don't have the overhead of each time. The database can use this. And someone was mentioning like roll-ups and stuff like that as well, which the database can use the roll-ups, the materialized view. Hopefully, let's try this out. Not a single group function. What have I done wrong here? There we go. So let's just get the thing. It still uses the materialized view, even though we've aggregated at a higher level. So the database is really smart about this stuff. So this is what I would do. So that was that. I'm aware we've kind of like gone way over today. I'm sure some of you need to head off. So I'm going to run through the things quickly and say what I would do, and then we'll finish up. And let's think. So sequences versus GUIDs. Like the big advantage of sequences is they're smaller, they're just more user-friendly, easier to understand, and things like that. GUIDs, however, they are globally unique. It's, global unique identifier, right? So the reason I would use GUIDs is if you are integrating. Someone mentioned this. Maybe you've got external systems you're bringing information from, or it's imposed by an external system, then you're going to store that GUID anyway. Why generate another sequence value as well? But generally, I much prefer sequences. I think they're just simpler, easier to work with. So unless there's a strong requirement to use GUIDs, I would stick with sequences. Blockchain versus trigger. Like I say, the big advantage of blockchain tables is it guarantees you can't change things. It's baked into the database. But with trigger, there's less storage overhead, right? We don't need to store that the hash of the data and store that cryptographic hash. So in some cases, if you are in a very heavily audited or regulated environment, you might need or want that blockchain table. But most times, I think a mutable table is a good halfway house between these. So I'd create a mutable table and consider separate tables for updatable columns. So there isn't necessarily, this is one where you have to kind of think carefully about what your use case and requirements. What are you preventing? What should be updatable? Why should it be updatable? Does it actually make more sense to store that in a separate table? Major and minor versus minor only. As we saw, major and minor, it just more closely reflects what end users expect to see, right? We can select the values and it's more or less, maybe a bit of rounding, exactly what the customer needs to see. Whereas with minor, it's more flexible. If we start dealing with currencies with different numbers of units, it's easier to kind of just handle that because we always just kind of multiply and convert to the major unit in the future. Ultimately, I don't think there's really a strong winner here. I know most people voted major and minor. The only real thing to say here is just make sure you document it, right? Choose an approach, stick with it, document it, and consider using things like annotations in 23C to help you understand that better. Storing versus calculating, as many people said, storing, we get faster queries. We don't need to do the group by and the total. Whereas calculating, the values are always in sync with whatever the subtotals are, right? So again, as I say, what I would do, the first thing I would look at actually is creating a fast refreshable materialized view to store the results. And only then start doing this trade-off of storing versus calculating if we can't. There's lots of restrictions, sadly, with fast refreshable materialized views. Only start doing this evaluation if we hit one or the other. Finally, addresses, inline versus separate table. As you saw with inline, it's much easier to stop people editing in an address and just affecting all your invoices throughout your application. But as many people said, the separate table is the correct relational way to do it. So what I would say is, generally, I'm a relational guy. I think, the relational model is the very good and important thing. But I would look carefully about how we can manage that impact of someone updating an address and it just like potentially invalidating all your existing invoices. As long as you've got a plan or a way to manage that separate table, I would absolutely support. Otherwise, inline, particularly for environments where editing address, delivery, and payment address is something that is just absolutely disallowed, storing things inline might be the way you kind of force down to. So, like I say, I know we've kind of got way over our normal time schedule, but I think the main point here is we've discussed lots of options, and I don't think any of them were necessarily truly bad options. They all had a trade-off. And the tagline was, help me design the perfect database schema. Well, hopefully, one of the things you might realize is that perfect doesn't exist. There's no such thing as the perfect database schema. There's just the one that suits the requirements you have. And, you've got to decide which trade-offs you're willing to make, what are the pros and cons, which things work better for you or worse for you in a particular environment. So it's up to you to make that decision. And this is where your skill as a database designer or DBA or developer comes in to analyze these trade-offs. And really, I think it's more about avoiding the truly bad options, right? It's not necessarily choosing the best option, but making sure you're doing something that is not tragically bad, right? Finish up. If you want some more free resources to learn about or access Oracle Database, we've got a whole stack of resources. I'll add these to the links to the office hours and appear in the YouTube video. Finish up. Normally, we've got doing something a bit different next month. So normally, SQL office hours is on the third Tuesday in the month. We're moving a bit forward next month. So it's in just 2 weeks' time. So Tuesday, the 5th of December. The next one would be a bit too close for Christmas. I'll be probably on holiday, and I think many of you will be too. So Tuesday, the 5th of December, and again, we're doing something different. I'm going to have Martin Bach, my colleague. He's managing JavaScript in the database, and we're going to be walking through a live lab, right? So he's going to do some introductions, and it'll actually be for you to walk through the process on your computer, doing the live lab, understand how JavaScript in the database works. So that is just in 2 weeks' time. It's already updated, so check that in your calendar. With that said, all that's left for me to say is I really hope you enjoyed this. More importantly, I hope you learned something, and I hope to see you in December. Goodbye.